In this tutorial, we will learn MongoDB indexing in depth. You'll understand how indexes work to speed up queries, optimize read operations, and improve overall database performance. MongoDB indexes are essential for index creation, efficient sorting, faster queries, lower storage overhead, and better lookups. By creating an index on a field, MongoDB can quickly locate documents without scanning the entire collection, which speeds up query performance. Indexes also allow for efficient sorting on specific fields, reducing the need for extra computation. While indexes do use some disk space, carefully chosen indexes minimize storage overhead and improve read efficiency. Overall, indexes enable faster lookups, optimized queries, and more responsive applications, making them a crucial part of database design and performance tuning. In the students collection, we have 4 students, Evan, George, James, and Lily, with courses CS 100, CS 101, CS 102, and CS 100 respectively. By creating an index on the course field using DB, students create index course 1. MongoDB builds a lookup table that maps each course to the IDs of the students enrolled. For example, CS 100 points to IDs 1 and 4, Evan and Lily. CS 101 points to ID 2, George, and CS 102 points to ID 3, James. When querying for a specific course, such as CS 100, MongoDB uses the index to directly access the matching documents, avoiding a full collection scan and making queries faster and more efficient. This demonstrates how an ascending index on a field can optimize lookups and retrieval in MongoDB. In the students collection, we have 4 students, Evan, George, James, and Lily, with courses CS 100, CS 101, CS 102, and CS 100, and ages 22, 35, 45, and 25, respectively. We first create a text index on the skills field using DB. Students create index skills text, which allows us to run a search like DB students find $text, $search, JavaScript. This query returns all students whose skills array contains JavaScript. Next, we create a compound index on course 1, age, -1, to optimize queries that filter by course and sort by age in descending order. Using this index, the documents are organized as follows: CS 100 Lily, age 25, Evan, age 22, CS 101 George, age 35, CS 102 James, age 45. The index allows MongoDB to quickly locate students by course and efficiently sort them by age, improving query performance and avoiding full collection scans. In the students collection, we have students Evan and George. Evan has skills, JavaScript, HTML, Java, and George has skills, R, Python. We first create a text index on the skills field using DB. Students create index skills text. This allows the query DB students find $text, $search, JavaScript, to return only students whose skills include JavaScript. In this case, the query returns Evan, ID 1, while George, ID 2, is not returned because his skills do not include JavaScript. Additionally, we can create an ascending index on the course field using DB. Students create index course 1. With this index, documents are organized by course, which allows MongoDB to quickly locate students like Evan when filtering by course, avoiding full collection scans and improving query performance. To create an index in MongoDB Compass, first navigate to the desired database and select the collection where you want the index. Then, click on the Indexes tab at the top and press Create Index. In the dialog that appears, enter the field name you want to index, such as course or skills, and choose the index type, e.g., ascending, descending, text, hashed, or compound. After selecting the field and type, click Create Index to generate the index. This index will now be used by MongoDB to speed up queries, improve sorting, and optimize lookups on the indexed field. You have successfully mastered indexing in MongoDB. By learning how to create indexes and understanding how to use them to optimize queries, sort data efficiently, and improve lookups, you are now equipped to design high-performance MongoDB collections. With these skills, your applications can retrieve data faster, reduce unnecessary scans, and handle large datasets more effectively.